This is day 3 of pre-calc review, and today we're going to solve logarithmic and exponential equations. So we're going to start off with just a little itty-bitty review. So log base m equals exponent. This m has a name, and this is called the argument. A-R-G-U-M-E-N-T, if I can spell argument. Okay, you need to know that word because I will use it tonight. So, when we start to talk about logs and exponents, there's some logarithmic form that we need to know. One of the things that we have is problems that have a base e. Base e is how things grow and decay in nature. It works like a pi. Pi is 3.14, e is approximately 2.71. But we always leave it as e. So e raised to the negative 2 equals this. So if I asked you to rewrite this into logarithmic form, I'm just going to put it over here since I've got my little arrow there. My base is e, and with an e we always have to use a natural log. Natural log base e, the argument of 0.1353, and we usually carry these to 4 decimal places, and it equals negative 2. That would be my problem. Now, something that I'm just going to highlight real fast. This base e is always understood, so if you don't want to write the base e, you don't have to. So, I'm quiet for a second. You try writing that problem quickly. Okay, I said quickly. So the natural log base e of 0.3679 is going to equal negative 1. Okay, so we need to be able to convert back and forth and do it fluently. So we're going to do the same thing now, but we're going to start with the log and go. And please remember, what's the understood base that's hooked on to both of these? You guys need to know that it's automatically a base e. So if I write this exponentially, my base is e. It is raised to the negative 0.6931 power, and it's going to equal 0.5. Same way here. I know that this base is an e, so I know this is e to the first power, or I'm sorry, e to the 0 power equals 1. This is a fact that we know. What's anything raised to the 0 power? Okay, so solve for x, 3 decimal places in your answer, please. So you will have to use your calculator, and I'm going to tell you when we get to that calculator spot, you need to try it on your calculator, and you need to kind of work through it and make sure that you know how to run it. And if you need help, you got to ask, because that's what I'm there for on Friday, Monday, and Tuesday. Okay, so solve for x, 3 decimal places. I see that my x value is stuck up here in the exponent. So the only way that I can bring that down is if I use some logarithmic rules. And that means I am going to introduce a natural log on the left side, and I'm going to introduce a natural log on the right side. When I do that, remember the rule from 2 days ago. The exponent, natural log of 2x, comes out in front, and then I'm left with the natural log of e would equal the natural log of 12. So I introduced a natural log on each side. If you wanted me to rewrite it, it would have looked the natural log of e raised to the natural log of 2x power equals natural log of 12. I skipped that step and I went straight to this because all that does is come out in front. Okay, so we're here. Well, guess what? There is something you better remember from 2 days ago. The natural log of e is 1. So now I'm just left with the natural log of 2x equals the natural log of 12. Okay, so some of you, depending on which teacher you had, you may remember dropping logs. You can cancel only one log from the left side and one log from the right side. So they have to be condensed. That's why we've done this. So I just dropped logs there, and I get 2x would equal 12. X would equal 6. Okay, so now I kind of look for all of this stuff, and I'm going to tell you, when you start with a natural log, you must check your answer that the argument's always positive. If you start it with an exponent, no need to check. So let's take a look at the next example. The next example, can you see that my variable is stuck up there in the exponent? So I'm going to have to use natural log rules. This has a log in it already, so that can just come down in front. So negative x natural log of e equals 0. Hey, we already talked about the natural log of e is the number 1. So I'm left with the negative x equals 0. Guess what? X equals 0. But there's common rules or rules that you need to just know. And one of the rules is if ln or log is in the original problem, then you must check your answer. Must check answer. And what are you checking for? You need to always make sure that the argument is positive. Argument must be positive. Must be positive. Okay, so I take the 0 back in, and I plug it in, and that gives me e to the 0 power. Anything to the 0 power is 1. Works. Check. Solution. Okay, so when I'm over here reading, it says step 1, force a common base or take the natural log of each side. Remember to isolate the base with the exponent. Use all the log rules needed. That's what we've been doing. And going to go to an example down here. And notice in this example that the variable is stuck up here in the exponent, so I'm going to have to use some natural log rules. Before I introduce a natural log, I isolate that part that I highlighted in yellow. And I'm going to do that just by dividing by 4. So e to the x would equal, and this is not a nice number, 83rd fourths. That's okay. So what do? I need a natural log to get that out of there. So I introduce a natural log on each side. And when I do that, that exponent's going to come down in front, and I will end up with x natural log of e equals the natural log of 83 fourths. We all know that the natural log of e is 1. Guess what? I'm done. X equals natural log of 83 fourths. Now, you need to try this on your calculator. You need to come up with the answer of 3.032, which is the non-rounded number, or 0.033. If you can't come up with either one of those, you're putting it in incorrectly. Come see me. We got to fix it. Okay, so I had to isolate that term first. Let's take a look at the next one. Notice where my variable is. It's stuck in that exponent. So first thing I got to do is isolate. I'm going to add 6 onto each side, and I'm left with 3e to the x equals 14. It's still not isolated. E to the x would equal 14 thirds. Okay, so now I need a natural log to pull that down. So introduce it on the left and introduce it on the right. And now that exponent can come down in front, and I'll have x natural log of e equals the natural log of 14 thirds. Oh, we know that the natural log of e is 1, so I'm left with x equaling natural log of 14 over 3. Again, you need to try that on your calculator, and you should come up with 1.540. And there's no rounding for that. Okay, so I need to zoom back up here. We have completely done number 2. We have not done anything from number 1, so I want to add in a problem, and I'm going to put it in black ink. To show you to force a common base, the problem is 25 raised to the 4x power is going to equal 125. Do you see 25 can be rewritten as 5 to the second power, and then it's raised to the 4x? And 125 can be rewritten as 5 to the third power. So this is 5 to the 8x power would equal 5 to the third power. What do you think happens when you've got a common base on each side? You're right, they go away. And I'm left with 8x equals 3. X would equal 3/8. So I wanted to show that common base. But you got to have numbers that start out nice. I've shown you numbers that don't start out nice, so it would work both ways. On to the back. So we've got some more equations to solve. So I am looking at this, and I see the variable that I want is right here. It's in an exponent. It's stuck on the bottom. First of all, how the heck do I get it out of the fraction? First thing I'm going to do is cross multiply. And I know that some of you have issues with cross multiplying. Think of this as 2 over 1. So when I cross multiply, I get 2 times that 1 plus e to the 2x power equals 5,000. Now, that variable is still stuck in my exponent right there. So, isolate it. First thing I'm going to do is I will divide by 2 on each side. And when I do that, I'm left with 1 plus e to the 2x equals, I just lost track, 2,500. Sorry about that. And then I'm going to subtract 1 from each side. E to the 2x is going to equal 2499. Okay, now that that variable is isolated with that e. So now I'm going to introduce a natural log on each side, because as soon as that natural log is introduced on both sides, that brings my exponent down. So now I really have 2x natural log of e equals the natural log of 2499. The natural log of e is 1. Boom, gone. So I'm left with 2x would equal the natural log of 2499. And x is going to equal the natural log of 2499 divided by 2. This problem is different on the calculator than the previous problems. This should turn out to be 3.911, and this should be 3.912. You should have those numbers on your calculator. If you can't, talk to me. We've got to figure it out. Okay, on to the next one. And start to try these without me and then check. This has a natural log in it. It actually brings that exponent down in front. So now I have 2 natural log of x minus 2 equals 12. I got to get that x out of that natural log. Look at where this x is? It's in, oops, sorry, I thought I hit that. It's in the argument. So we're going to keep working to get that natural log by itself. And that natural log of x minus 2 is going to equal 6. But now I need to get that out of that. So how do I do that? I have a natural log. I can't do anything else. Go the other way. Remember, your base is e. I am going to rewrite this as e raised to the 6th power equals x minus 2. Oh, the x is going to be by itself. E to the 6th power minus 2 would equal x. And that is a calculator problem. When you go onto your calculator, 405.429, I am telling you, check how to do it on the calculator. Last one, try it by yourself, but hint, did we ever have square roots and natural logs? Day 1 lesson said no, rewrite it. Natural log x minus 3 raised to the 1/2 power equals 2. Ooh, we got a natural log. The exponent comes down in front. And I'm left with 1/2 natural log of x minus 3 equals 2, which means I'm going to multiply each side by 2, and I'm going to be left with the natural log of x minus 3 equals 4. Okay, we can do this. I got to get that x out of there. It's already got a natural log in it. Remember, there's an understood base e hooked onto that. So I'm going to rewrite it exponentially. E to the 4th power would equal x minus 3. E to the 4th power plus 3 would equal x. Yay! And do that on your calculator. X should equal 57.598. Lot of equations. Last one. It said draw the functions and confirm that they're inverses. So I don't know what you guys remember about graphing. When I am graphing this function here, I'm going to be doing it in yellow. And hopefully you guys at least remember a couple of things. And if you don't, oops. First of all, let's get rid of that blob. Hopefully you guys remember x, y chart. If I let x equal 0, this is e to the negative 1 power, or 1 over e. If I let x equal 1, I get e to the 0 power, which is 1. And if I let x equal negative 1, I get e to the negative 2 power, or 1 over e squared. Okay, so what is that thing going to look like? Well, when x is 0, I'm on my graph, so I'm going to give me some points here. So here's 1, here's 2, here's 3, here's 1, here's 2, here's 3, 1 and 2 and 3, and 1 and 2 and 3. Okay, so graphing this, I would be graphing it at 1, I'm at 1. Oops. It helps if I actually hit the point at 1, I'm at 1. At negative 1, I'm down here. At 0, I'm here. I can get an idea that my graph would look something like that. Okay, so then comes along, and now I am going to graph this one. And a natural log graph, again, not sure if you guys remember what they look like. If I plug in 0, natural log of 0 is 1. 1 plus 1 is 2. So at 0, oh, I just did that wrong. Silly me. And you guys, you have your calculators to help you if you need it, a little of this. But with your x and your y values, if I plug in 1, the natural log of 1, you are going to see that it gives me an answer of 1. My value is 0. So when I'm at 1, I'm at 0,